So last time we had the case of 3 unknowns and 2 equations. This time we have 2 equations. That's not true. We have 2 unknowns and 3 equations. This is overdetermined. There's too much information. We only need 2 equations and 2 unknowns to have a value for x and y. What happens when you have a third? Well, we know it's going to look a little different in our augmented matrix. 2, 4, 6, minus 1, 1, 5, 4, 3, 1. What does this mean geometrically? Well, these are lines. But what can happen with 3 lines? Well, they could all intersect, right? That's possible. So you could end up with an x and a y that satisfy these 3. That's unlikely because I just made this problem up. You could have 3 lines that all mutually intersect. So any pair of them have a solution, but there's no xy. That would be no solution. You could have 3 parallel lines, and that would also be no solution. These aren't 3 mutually parallel lines, though. Right? I mean, the slope is it's like a half, a sixth, and a fifth, so they're not parallel. And they could be all the same, line, which they're not either. How do we solve these? Well, let's run through it and see what happens. Okay, same idea, starting with this being equal to 1. So we're going to do 1/2 of row 1. So half of that would be 1, then 2, then 2. The other rows and columns are not affected. Let me pause this. And all right, so our next goal then is to make this equal to 0, which we'll do by taking row 2 minus 6 times row 1. So that means row 1 does not change, and row 3 does not change. Row 2 has 6 minus 6 is 0. Minus 1 minus 12 is minus 13. And then 3 minus 12 is negative 9. Next goal is to make this one equal to 0. Okay. So we'll go over here. And to do that, we'll take row 3 minus row 1. So row 1 doesn't change. Row 2 doesn't change. Row 3 is a 1 minus 1. Then it's going to be a 5 minus 2. That's 3. 1 minus 2 is minus 1. Our next goal is to make this equal to 1. So we'll do that by taking negative 1/13 of row 2. So row 1 doesn't change. Row 3 doesn't change, and row 2 of a 1 there, and then a positive 9/13. Our next goal is to make these things both 0. We'll just do, say, this one first. We can do that because we have this 1. So let's do row 3 minus 3 times row 2. So row 1 doesn't change. Row 2 doesn't change. Row 3, 0 minus 0. 3 minus 3 is 0. And what do we have here? We have a minus 1 minus 27/13. All right. Okay, and so that's 13/13, so this is 40. This is minus 40/13. Now this is actually as far as we really need to go. And I'll show you why. Think about, look at this. Why are we done? Remember, we're not expecting a solution here. Chances are these three lines don't intersect at one common point. And that's apparent now from this augmented matrix. To see that, let's look back. Right now, the matrix says x plus y is 2. It says that y is 19/13. And it says that 0 equals minus 40/13. Because this is 0x plus 0y. So what's this? This is a contradiction. It's false. So this means there's no solution. Don't bother solving the rest of it. It's not going to be true. There's no solution. No surprise there. Okay. So that shows you another case of these elimination method problems. This was overdetermined, too much information. The previous example was underdetermined. We had an infinite number of solutions. The previous one before that, there was one solution for 3 planes. Okay?